Welcome to this explainer on the NIST AI Risk Management Framework. Today, we're giving you a detailed summary of this absolute must-read document, figuring out exactly how organizations can responsibly tame the Wild West of artificial intelligence. I mean, if you're building, buying, or deploying AI, this is your ultimate playbook for turning wildly unpredictable tech into something safe, secure, and above all, trustworthy. Let's get into it.
Let's kick things off with a pretty fascinating quote straight from the NIST framework itself. It really hits the nail on the head regarding a major blind spot we all have. We tend to blindly trust AI, right? We just assume it's perfectly objective or somehow inherently superior to standard software. But that very assumption, that AI just works flawlessly in all settings, is exactly why we absolutely need a structured, deliberate approach to managing its risks.
So here is our roadmap for today's detailed summary. First, the unique risks of AI. Second, defining trustworthy AI. Third, govern, which is all about the risk culture. Fourth, map, understanding the context. Fifth, measure, tracking and testing. And finally, number 6, manage or mitigating AI risks. Let's jump right in.
Starting with Section 1, the unique risks of AI, unpredictable dangers. Let's explore exactly why managing AI isn't just another standard IT project.
The contrast here is honestly pretty stark. Think about traditional software like a basic calculator. You rely on predictable rules. You put X in, you know you're getting Y out. But AI systems, they're much more like a growing plant. They're trained on dynamic data that changes over time, sometimes totally unexpectedly. They experience what we call drift, meaning their behavior literally evolves after deployment. Plus, they carry emergent risks and can be incredibly inscrutable, which makes it incredibly tough to spot and fix failures when they inevitably pop up.
So here's the crucial takeaway. AI systems are inherently socio-technical. This is a massive concept in the NIST framework. It means AI isn't just lines of code running silently on a server somewhere. It is a highly dynamic interaction between algorithms, human operators, and incredibly complex societal contexts. The risks and the benefits, for that matter, emerge directly from how the system is used, who operates it, and the real-world environment it impacts. Why does this matter to us? Well, because ignoring the socio part is exactly why so many mathematically perfect algorithms fail spectacularly in the real world. You just can't manage AI risk by only staring at the math.
Moving to Section 2, defining trustworthy AI, the 7 characteristics. Let's look at how NIST defines the ultimate solution to these unique socio-technical risks.
To tackle those risks head-on, NIST outlines these 7 interdependent characteristics of trustworthy AI. Now pay close attention to this, because NIST explicitly reminds us that an AI system is really only as trustworthy as its weakest link. You have to balance these traits. For instance, making a system highly privacy-enhanced might actually make it less accurate, or ramping up security might limit its transparency. So, a solid risk management strategy requires making very deliberate, context-aware trade-offs among all 7 of these characteristics. It's a real balancing act.
Now, to actually achieve that trustworthiness and tame those risks, the NIST playbook hands organizations these 4 actionable core functions. We're going to keep moving through this detailed summary to show you exactly how each of these operates in practice.
Up first is Section 3, govern, the risk culture, cultivating accountability. Let's dive into this first core function.
Governance is super unique because it acts as this cross-cutting engine driving everything else you do. It demands that executive leadership, the C-suite, takes direct personal accountability for AI risks. It is absolutely not just an IT problem anymore, it's a top-down organizational mandate. And beyond that, governance requires demographically and disciplinarily diverse teams to spot those sneaky blind spots and avoid systemic biases when making key decisions.
Next is Section 4, map, understanding the context, anticipating real-world impacts. With our governance established, we now have to deeply understand the actual real-world context of our AI deployment. The map function literally forces organizations to hit the brakes and ask some vital, urgent questions before writing a single line of code or deploying a model. Who could be harmed? What could be harmed? When and how? This is your absolute frontline barrier for preventing negative impacts out on the wild. Basically, AI actors are strongly encouraged to engage with external stakeholders and potentially impacted communities to map out exactly how harm might play out in real life.
You also have to explicitly document an AI system's boundaries. Mapping requires you to clearly define the limits of the AI's knowledge and its dependencies. This is a huge deal when you're relying on third-party datasets or open-source algorithms, right? Sure, they accelerate development, but they also deeply complicate your risk measurement. You have to map out exactly what the AI can do, what it absolutely can't do, and exactly where the human operator fits into the loop.
That brings us to Section 5, Measure, Tracking, and Testing, Benchmarks and Metrics. Here is where we take all those meticulously mapped risks and put them to the test with cold, hard data.
So, in the measure function, organizations have to employ rigorous software testing and performance benchmarks. But because of the totally unique nature of AI, this can't just be some internal echo chamber. The framework highly recommends processes for independent review to mitigate internal biases. You really need that independent outside layer to continuously monitor the system and see how it holds up against those 7 trustworthy characteristics we looked at earlier.
Notice the 2 distinct categories broken down here. Tracking has to go way beyond just the code. We have to measure both the technical performance, like your accuracy and security, and the socio-technical impacts. We're talking things like fairness, equity, and how humans are actually interacting with the final output. Both sides of this coin are absolutely critical if you want true, holistic risk measurement.
And finally, Section 6, Manage, Mitigating AI Risks, Prioritize, and Respond. This is the action-oriented function where we finally deal with all the risks we've just mapped and measured.
Now, trying to eliminate all risk entirely is usually impossible and, frankly, counterproductive. And honestly, it is so refreshing that NIST explicitly admits that. Instead, depending on the risk tolerance defined by leadership way back in the govern phase, you have to proactively decide how to respond. You can mitigate the risk, transfer it, avoid it entirely by altering the system, or simply accept it if it falls within your organization's tolerance levels. From there, resources are allocated to tackle the most severe risks first.
Crucially, the NIST playbook mandates having a solid safety net. If a system exceeds your risk tolerance or starts behaving inconsistently with its intended use, you can't just let it run wild. You must have mechanisms in place to supersede, gracefully disengage, or completely deactivate the AI system. Think of it as a mandatory, well-engineered kill switch to prevent any imminent or severe harms.
And remember, management is never a one-and-done event. When you look at pre-deployment planning versus post-deployment reality, it becomes abundantly clear that your job isn't over just because the system is live. Because AI systems constantly drift and adapt to new data, continuous post-deployment monitoring is an absolute non-negotiable requirement to actually sustain the AI's value and safety over time.
Because AI continuously adapts and learns, we want to leave you with this final provocative thought. If you aren't governing, mapping, measuring, and managing on a continuous, never-ending loop, what exactly will your AI system learn to do tomorrow? Thanks so much for joining this explainer, and we will see you next time.